Task 3.4. Understand security capabilities of information systems. A crucial area of the CISSP exam that you'll be tested on, covering concepts like memory protection, trusted platform module, and encryption-decryption. And before we begin, if I don't go as deep as you like, remember that's what the prompt at the end of the section's for. 3.4 has no subtasks, but we are going to focus a little bit of our attention on three important principles: memory protection, trusted platform module, and encryption and decryption. Memory protection. Some key things to remember about it. 1. Preventing unauthorized access. It implements controls to restrict unauthorized read and write access to memory. It's very crucial. If an attacker gains access to system memory, they could potentially read or inject malicious code. 2. Protecting data integrity. The mechanisms ensure that data stored in memory isn't tampered with by malicious software or accidental misuse. This is essential for maintaining the trustworthiness of running processes and stored data. 3. Isolation techniques. Modern operating systems use techniques like segmentation and paging to isolate processes from another. This prevents processes from one accidentally or maliciously interfering with another's memory space. And 4. Application in operating systems. Memory protection is an integral part of modern operating systems. And it's not just about security, it's about maintaining system stability by preventing processes from interfering with each other or with the operating system itself. Now remember, the CISSP exam may present scenarios where you need to identify potential memory-related vulnerabilities and recommend appropriate protection mechanisms. Think about how these concepts might apply in real-world scenarios, such as protecting against buffer overflows or securing some multi-user system. TPM, or Trusted Platform Module. This is a hardware-based security feature that provides a dedicated microcontroller designed for secure operations. Here are some key aspects of TPM you need to understand for the exam. 1. Hardware-based security. Unlike software-based security solutions, TPM is a physical chip on the motherboard. This hardware implementation makes it significantly more difficult for attackers to compromise. 2. Platform integrity. The primary function of TPM is to ensure the integrity of the system. It does this by storing cryptographic keys and measurements of the system's hardware and software configuration. It allows for the system to detect if it's been tampered with. 3. Secure boot. TPM plays a crucial role in the secure boot process. It verifies each step of the boot process to ensure the system hasn't been tampered with before it starts. It helps prevent boot-level malware and other low-level attacks. 4. Data encryption. While TPM doesn't perform the actual encryption, it provides a secure environment for cryptographic operations, including a true random number generator, a hardware-based random number generator, for creating session keys. And of course, it stores private keys. It's important to note that while TPM provides robust security features, it's not a silver bullet. The CISSP exam presents scenarios where you need to evaluate the appropriateness of TPM in different contexts and its limitations. Encryption and decryption. For the exam, you need to understand three major categories of encryption algorithms. 1. Symmetric algorithms. These use the same key for encryption and decryption, and it's used for data. Examples are AES and maybe triple DES if you still bump into it. 2. Asymmetric algorithms, known as public key algorithms. They use a pair of keys, one private and one public. They are used for exchanging the symmetric key and for authenticating hash values, which is our next section. Hashing algorithms use a fixed size output from any variable size input and are used for detecting changes or integrity issues. Now, it is not encrypted in a way that it can be decrypted. It is strictly one way. SHA is the best known system, and MD5 is considered insecure. The exam may test you on your understanding of these. It's crucial to understand how the different algorithms work together in real world. Symmetric encryption is used for data, hashing used for data integrity, and asymmetric encryption again is used to encrypt symmetric keys or key agreement, key sharing, or to authenticate a hash, also known as signing. Remember, the CISSP exam isn't just about knowing the algorithms, but understanding when and how to apply them in various scenarios. All right, summarizing our understanding here. 1, we talked about memory protection. We learned about mechanisms that prevent unauthorized access and manipulate memory, crucial for maintaining system integrity and security. 2, the TPM, or Trusted Platform Module, a hardware-based security solution that's used for both the integrity of the boot process, and we can also use it to create keys and perhaps encrypt your disk, right? And then 3, encryption and decryption. We discuss symmetric, asymmetric, and hashing algorithms and how they work. So let's put our knowledge to the test on the next slide here. All right, give it a try. Get in there, run this prompt, your favorite, it runs on all of them, and play with section 5 again. Larry didn't go deep enough for me. See you soon.